However, my slides are over here, so if I keep looking that way, that's why. I'm not trying to ignore you unless you ask me some really awkward questions. Then I'll start trying to ignore you. But my name is Kevin Feasel. I run a predictive analytics team out of Durham, North Carolina. I'm a data platform MVP, and I have a blog called Curated SQL. The idea of Curated SQL is I want to try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. That's curatedsql.com. So what I want to do in this talk is help you understand what the purpose of the serverless SQL pool in Azure Synapse Analytics is, especially in contrast to dedicated SQL pools. And then we're going to spend a lot of time loading data with them, querying data from them, and getting a feeling of how much it costs and how to lower that bill a little bit. So I'm going to assume that you've probably sat through a couple of sessions already here with outstanding speakers talking about what Azure Synapse Analytics is, which means this overview will be a little bit brief. Azure Synapse Analytics, being the platform for modern data warehousing in Azure, is made up of 4 primary components: dedicated SQL pools, Spark pools, the serverless pool, and brand new in preview, just announced, Data Explorer pools. So in order to understand serverless SQL pools, we kind of have to understand the converse, the dedicated SQL pool, and see how they differ, contrast them. Dedicated SQL pools, previously Azure SQL Data Warehouse, give you this massive parallel processing approach to data warehousing, where I'm going to have my compute spread across some number of different nodes working in concert with one another. This works fantastic with Kimball-style fact-dimensional warehouse models, assuming that you have at least a terabyte of data. If you have a lot less than a terabyte, it may not even be a good fit for you. As you get more and more data, tends to be a better and better fit. Also, that your fact tables, hopefully your largest ones have at least 1 billion rows. Kind of you must be this tall to ride the ride type of deal in order to get the best performance out of this, especially when using clustered column store indexes with partitioning of data. Your dimension tables in the Kimball world generally are going to be pretty wide, but very short. Thousands of rows, hundreds of rows, maybe tens of thousands of rows, generally not getting past that. Maybe 1 million rows, but that gets a little tricky. And users are usually working with a particular set of business needs. I have these reports to fill out. I've got this documentation that needs to be sent to this regulatory agency. I have these specific known requests. I want to know what the quarterly year-over-year revenue is for each business unit, as an example. So we build out a warehouse to solve those types of needs. Spark pools give us the ability to spin up Apache Spark clusters and do more complicated data transformation that is not really easy to do in T-SQL. There's a great example of that. Working with regular expressions, can't really do it in T-SQL. You can kind of do a little bit, but not much. Distributed machine learning tasks that, again, are these may not be suited for Azure Machine Learning because you have so much data that you're processing across a very large cluster. Or if you're already really familiar with Apache Spark and you just want to do a lot of work in Spark, that's where the Spark pool can help you out. Let's talk serverless versus dedicated. So a serverless pool is a little bit different from a dedicated SQL pool because the serverless SQL pool does not store data. It's going to read files directly from a data lake and expose them as SQL tables, potentially. At the very least, it'll expose the results of files that are in your data lake as result sets that you could query. The serverless pool does not require infrastructure or resource reservation and will have no upfront costs. So you could have a serverless SQL pool just sitting there, not have to pay money until you use it. This is quite unlike a dedicated SQL pool where as soon as you start it up, if it's running, you're paying. You can pause it, destroy it, and you'll stop paying. But with the serverless pool, there's nothing to pause. The pricing model starts at $5 per terabyte of data processed. We'll talk a lot more about what that implies and what gets included in the calculations in near the end of the talk. Major use cases for this serverless pool. I think the most interesting one is data spelunking. I have some ad hoc query. I'm doing some investigation, and I don't necessarily want to go through the process of getting this into my warehouse, because if you've worked with a BI team, you typically have a problem where I need to perform an analysis on this thing. And okay, that's great. We figure out where it is in the source system, and then it's going to take us about a 6-week sprint in order to get it finished, because we have to update ETL processes, have a bunch of new scripts, script out the new columns, get those columns updated and backfilled, and make sure the process is working. And then if I do my analysis and I find out maybe that column actually isn't important, then I've wasted 6 weeks of the BI team's time. I'm not going to tell them that. Nobody's going to tell them that. That column's going to sit there and nobody will ever use it. And it's just a loss for everybody. The serverless pool allows me to do a quick query, and I can say, oh, yeah, that's actually really useful information. I need to know that every week. Now I can engage and get that into my enterprise data warehouse. You could go a step further with this concept into logical data warehousing, where instead of having a real dedicated SQL pool with Kimball-style fact-dimensional modeling, with all of the preparatory work, the ELT involved in maintaining this thing, what if I just have a set of views or external tables that expose data in files? And if I only occasionally need this data, like if, for example, I have a Power BI dashboard I'm updating once a day, then I may not need all of the excess with setting up all of this pool. Also, simple data transformations, the types of things that maybe I'm changing the file formats, or I'm doing some cleanup that T-SQL is good at. I could do that within the serverless pool, write it back out to files, and use those files later on. Data Explorer pools, the last thing, like I said, brand new. They allow you to do real-time analysis on large volumes of data. I think they're going to be pretty interesting. I've not used any of them yet. I just, since we learned about them publicly last week, so haven't tried it out yet, but it is on my to learn list. So now let's talk about, how do you create a serverless SQL pool? Actually, the short answer, you don't. Well, you create a workspace. The Synapse workspace will automatically give you one built-in serverless SQL pool. And you cannot create a new one. If you try to select new for SQL pool, that'll give you a dedicated SQL pool. So you can't have a second one. You can't accidentally delete your existing serverless SQL pool. So you can't really create or destroy. And that's okay, because again, if you're not using it, you're not charged for it. Now, let's talk about querying data. And by the way, if you do have questions on anything that I talk about, drop it in chat. Like I said, I am watching you. I'm watching you, chat. Querying data. We work for an agency, the Martian Agricultural Data Collection and Ownership Agency, and I chose that specifically for the acronym, just like in real life. That's how all government agencies are named, I'm pretty sure. So our job is to collect sensor data. We've got agricultural plots on Mars. This is, by the way, the year 2121. So obviously, I didn't need to tell you the current year, I'm sure. And our systems collected a lot of data from IoT devices on farm plots all across Mars. We decided to use Azure Synapse Analytics to perform some analysis. And specifically, we're going to use the serverless SQL pool to do all of this work. So how do we query this? Well, you're going to use T-SQL, and this will be roughly the same T-SQL language that you know and love from SQL Server on premises. I say roughly, there are differences. Like, for example, you're not going to be able to directly insert, update, delete data within tables. So you're not really going to need to insert, update, or delete. There is some functionality that is not in serverless SQL pools that is available in SQL Server on premises. Like, for example, anything with, say, machine learning services or using the CLR or several other aspects, not going to be available here. But the mainstay logic within T-SQL is the same. So these pools are almost entirely read-only. Like I said, you don't really insert, update, or delete data. You don't merge. I mean, you don't merge in general, but that's a rant for another day. So how do we load this data if it's read-only? Seems like a little bit of a paradox here. Well, you can bring in data from someplace like Azure Data Lake Storage. And by the way, your Synapse Analytics workspace will have an associated Data Lake Storage account already available to you. You can, of course, bring in another managed endpoint for a storage account if your data lake actually exists outside of Synapse Analytics. Then you have that data. So that data is out in a storage account someplace, and we can use the open row set command in order to bring this data into us. I have here, select top 10 star from open row set. Inside open row set, we have a few settings. So this is first going to give us the location of our file. So I'm using the ABFSS protocol with Data Lake Storage. And where is your Data Lake store? And then what folders and what files. So in this case, we're going to have a file Arability Score _1.txt. We can define the format, parser version, how the comma separated values are really separated. Like in this case, it's really semicolon separated values. Little shout out to the Germans in the audience. And the first row will be number 1. So you can skip header rows. So as far as permissions to run open row set, my recollection is that you only need the writer permission on, or excuse me, not writer, geez. The, oh boy, you need workspace permission unless you want to connect to it through Management Studio, and you would want to have, I think the SQL admin permission is going to give you that ability. I'd have to go back and check the docs to see for sure. I always grant myself administrative rights because that's how I roll. But I know that the docs do give you information on the permissions needed. Unfortunately, I can't think of it off the top of my head. As we bring in this data set, we're going to label it. And SQL Server demands structure. Azure Synapse Analytics Serverless SQL Pools demand structure. We have structure in the sense of how many columns we have, what their names are, what their data types are. Notice that I don't specify null or not null. Just leave null and not null out. Let the system handle that on its own. And then we'll call this thing Arability. Virtual table is the term I was trying to think of, but we'll call it Arability and talk about the supported file types. So I gave you an example of a delimited file, which for the sake of common terminology, we'll call CSV, even though, as I showed, the delimiter does not have to be a comma. You can also use Parquet. You can read JSON files, and you can read from a Delta Lake. So you can use a serverless SQL pool to query Delta Lake formatted files. Speaking of Delta Lake, there is some support for the Linux Foundation's Delta Lake, and this was originally developed by Databricks, gifted out to the Linux Foundation, made open source. Delta Lake has got some good features like serializable transactions that are available, the ability to go back in time and see what a record looked like. Think about temporal tables in SQL Server. That time travel in Delta Lake is a similar construct. You have schema enforcement via use of the Parquet file format. So Parquet has a lot of structure available to it, making it better than comma-separated values in many cases, because it has metadata that includes column names, column structures, numbers of rows, numbers of columns, other information that would be useful for a lot of different types of analysis. And we'll see how that can save us money in the long run as well. And Delta Lake also gives, through Spark, the ability to insert, update, delete, and merge. So you can also use that via Spark SQL. Now, with serverless SQL pools, again, we're not going to insert, update, or delete data. We are, however, going to be able to read data. Can you connect to serverless SQL pools from Management Studio? Yes. Yes, you can, from my recollection, but we're not going to do that today. We're going to use the workspace here. So I have a database. Actually, I'm going to have to drop it down one spot so you can see my database, Mars Farming, that is already created, and I'm going to use it here. And I've got the same query that I showed before. Go ahead. All right, we're going to use the same query as before, and let's bring this up. See if we can get 10 rows. We do get 10 rows. And in case you're curious about the structure of this data, and that I get 10 rows, let's pop into Storage Explorer and see what we've got. So up here, I've got in my Synapse container within my storage account, a few different folders. One of them is raw data, which is just comma separated values files. And I've got a few different measures that are all tracked for different plots on the planet Mars over time. So how arable is the soil, different measures of gases, the pH in the water, the temperature, and how high quality is the water. So how much water are you actually getting for irrigation? We have these measures that are tracked by plot of land on Mars, and I could open it up and view what the values for one of those plots looks like. We've taken that data, we've already processed it into my poor man's data lake, into this curated folder by measure. We've got the year, we've got the month, and we've got a collection of Parquet files that represent the data across all plots. So within March of 2117, all plot data in here. And I did that so that we would have sufficient data sizes. So you can see that these files are actually pretty small. Even if I go back to the raw data, what I end up having is a few thousand or so lines per record. So it's somewhere in the order of 6 or 7 megabytes for a given plot. And the benefit here is that I've got about 9,100 plots. So that's where it adds up over time. In addition to that, there's some metadata, which includes what the plots are, where they're located, and who their owners are. So I've got some measures here that are going to be potentially of interest. The one that we're looking at right now is in this Arability Score. And as we see, for the first plot that's in the raw data, I get a plot ID, the report date and time, and what its Arability Score was. And we calculate this measure every 10 minutes, and we did that over the course of roughly 5 years. Let's go next and look at a couple of other ways of using this data once you have the open row set operation. Here again, raw data, Arability Score number 1, and I bring in my 3 columns. I'm going to say, give me the distinct set of years, just to show you that this is, in fact, 5 years worth of data. So it'll take a moment to run, and I have 2116 through 2120. So 5 years worth of data. Now, the next question is, well, what is the highest arability score? What's kind of the range of how arable our soil is in this system? And for that, I'm going to look at the curated data sets looking in the year 2117. One quick note is that you can use the asterisk to represent essentially all files within this directory or all files with this .parquet format name. So I can say in here, basically, I don't care what month it is. I don't care what the name of the file is. Look at all of them and give me the maximum arability score across them. And note as well that I don't have to specify the column names because I'm using the Parquet format. Because I'm using that format, the data types and column names are already part of the metadata, and the serverless SQL pool engine can read that, and then create my result set based off of it. That said, I'm liable to include them anyhow just for the sake of that documentation. So I would want to probably add the values as well on here just to have it. But we can see that the maximum arability score is 1.03, which is apparently it's not a percentage, although it was originally intended to be. But it ranges around 1 being really awesome and 0 being terrible. Next up, let's look at a different file format. So we've looked at CSV, we've looked at Parquet, look at JSON. There is no JSON format, so to speak. Instead, you specify CSV and have a field terminator and field quote of 0x0b, and that's going to allow you to read JSON files like this outcome.json. So if I pop open here and go back to metadata, I have outcome.json right here, and I could open this up, and it's probably going to download it and pop it up in Notepad. So I'm going to do that and open up JSON files with the world's greatest editor and IDE and development platform, Notepad. So we have 2 outcomes. Number 1, and outcome name. Number 2, outcome name. One thing I want to note is that in most cases, you're going to have JSON structures that look a little bit like this, because this is an array of JavaScript objects. And an array of JavaScript objects has commas separating the elements. So the problem is that if you include a structure that looks exactly like this, the serverless SQL pool will not understand it. You will have to have 1 line per object. May require making some modifications to existing outputs and maybe run it through sed. Sed fixes everything. Once we have files in that format, then we can query the document. So the document is a varchar max, and then we're going to pull out the individual values using the JSON value operator. In doing so, we'll get back our outcome and outcome name, as well as the JSON object notation, because I just included doc. So that gives us back our entire JSON set. If you want something that's a little bit more complete than 2 rows, we can look at the number of plots. And in here, again, same structure, format CSV, terminator and quote. I selected a row terminator just to show you that this attribute's available, \n. Again, bringing it as a dot, and I changed it to in varchar max because everybody knows in varchar is superior to varchar in all ways. Just leave that one out. So we have here JSON values for plot ID, owner ID, city, and size in acres. And I can see those values. So I've got different cities on Mars, as one would expect. And each one of these each one of these plots comes with approximately 40 acres and 1 space mule. So we've got all of that available to us. And now, with that in mind, let's talk about Polybase. I like Polybase. Azure Synapse Analytics extends this technology called Polybase, which is a virtualization technology. It allows you to virtualize data from a number of different data platform technologies. On premises, this includes a variety of things: Oracle, SQL Server, Teradata, generic ODBC. You can run against a Hadoop cluster, execute MapReduce jobs against that cluster. You could hit Azure Blob Storage. For more on Polybase itself, I've got a whole talk on it. I've actually got a whole book on it, but that book is dedicated mostly to the SQL Server version of Polybase. As far as we're concerned today, for our serverless SQL pool, we're going to mostly care about Azure Data Lake Storage Gen 2. So JSON can be deeply structured. Do we need to flatten it first and represent a flattened entity as a row with a comma on the end? The way that you would handle this, actually, you know what? I'm going to punt on that question because I would give you the Polybase answer and reading mostly from Cosmos DB. That's my experience with with deflattening, or actually with flattening JSON structures. So it may not be exactly the same here. I can tell you with Polybase, when you pull in a JSON structure from something like Cosmos DB or MongoDB, it's going to flatten out by creating one row per array element within an array in your object, which means if you have two object arrays, you're going to get a cross product of all of those combinations of rows. I don't know that I could tell you exactly what'll happen in this scenario. So I must unfortunately punt on that question. Let's talk a little bit more about Polybase. Three sorts of objects exist: external data sources, file formats, and tables. An external data source is a pointer. Where does that data actually live? It doesn't really live in our SQL Server instance or in our serverless SQL pool. That's not where the data really is stored. The data doesn't migrate to that location. It's not an ETL process that's keeping something up to date. The data always lives over on the source. And we can create an external data source using the create external data source command and give it a location. Like this is my my data lake storage location, say Mars farming _ curated, and give it a credential. So for this, we're going to need to use a Sas token to allow access, unless you have a publicly available data lake. There are reasons why you might want to do that. Strictly speaking, you have entirely public data, but for most companies, you're probably not going to want to do that, because then you end up on the headline of a newspaper in a way that is not flattering. So we use Sas tokens. How do I create a Sas token? Well, we'll talk about that in a moment. But if I have a Sas token already generated, I can create a database scope credential off of that Sas token. So Sas token write. That's the Sas token write in here. So it's an identity equals shared access signature. Secret equals the Sas token itself. And since I did ask, how do I create one of these? If I have my Synapse container here, and I'm going to pop back to the storage account, I can say shared access signature. And I can use this form right here to create a shared access signature. So generate Sas and connection string if I fill out the details that are necessary. If you're using Azure Storage Explorer, you can also create a shared access signature from that. And you can also create it from the AZ command line. So you could automate this process if you were doing this as part of a regular routine. External file formats are a way of telling the serverless SQL pool what is the format of this data that is on that external data source. And we can use comma separated, tab separated, Parquet format. We can use the orc format in Polybase, which was historically more associated with Hortonworks as opposed to Cloudera, and a lot less popular nowadays. Parquet has kind of landed as the norm. So I would assume work with Parquet. With Polybase, you can use Orc, but generally, if you have a choice, use Parquet. Now, a little bit more about Parquet and Orc. Both of these are columnar storage formats. What that's going to mean is that your data is not stored row by row like it is with a CSV, like it is with something, the Avro format, for example. Those are row-based storage. Row-based storage is fantastic if I need to scan quickly to a row, grab the details for a row, return those details. With a lot of analytics queries, though, we're not necessarily interested in the results of a row, and I can't jump to a row in a file and get the thing that I need. Instead, what I'm more interested in typically is the aggregation of a set of values, possibly filtered by some other attributes. Well, if I store the data in columnar format, I get a couple of benefits. One is I don't need to scan the entire row of a data set in order to get a column. By keeping those columns separated, I can scan the column itself and thereby have less data impacted. It will also typically be faster. Compression generally works much better on columns than on rows. The reason for that is columns are a data type. Think about numeric columns, and if you imagine a warehouse, a large fact table in a warehouse, you usually have a lot of repetition in the numbers that are seen. You may use a customer key, and if you've got 5,000 customers, you'll probably have a lot of rows with the same customer key. If you have product keys, again, you'll probably have a lot of rows with the same product key. Dates, you'll have a lot of rows with the same date. In those cases, we can compress that down extremely well. This is also the secret behind column store compression in SQL Server and in Azure Synapse Analytics dedicated SQL pools. Taking advantage of that is something that Parquet can do as well, which allows you to get smaller files, which allows you to get more data in the same amount of physical space, generally retrieve data faster if you're asking for aggregated queries of relatively small numbers of columns. If you're asking for all data across all columns, it's not going to be faster necessarily, but generally we don't ask for that. So here's an example of the CSV file format. We specify that the type is delimited text. So instead of saying format equals CSV, like with the open row set, we set a format type of delimited text. Because we use delimited text, we do have some attributes like field terminator and encoding. For Parquet, I'll say format type equals Parquet, and my only other attribute I can set is the data compression type. And there are two different types, snappy and gzip. And the difference between the two, one has a minor benefit for lower storage requirements, but at the cost of higher CPU. One has slightly lower CPU requirements at the cost of slightly higher storage requirements. So it's that storage versus CPU. One is slightly better than the other at each. On the whole, it doesn't matter that much typically. External tables, final object, going to tell you the structure of your external resource. Again, I use the term structure. That's because serverless SQL pools require structured data. We're querying it like it's a relational database. It will reject records that do not fit the data types and the sizes that you set. So if I have an external table, I create external table, and this part up here, except for the word external, looks exactly like creating any other type of table. So very similar syntax. Here's where it gets a little bit different because we have to specify where is the file located. So the data source, where's the physical location, the folder or the actual file itself, and in what format is this. In this case, we're looking at Arability scores in January of 2120 from the Mars Farming curated data lake storage count. So the Synapse container in my data lake storage account inside this Mars Farming curated folder. And the format is Parquet. All files inside there will be .parquet. I've shown open row set, I've talked about and will show Polybase, but I do want to mention you can combine the two together. You can work with both, not just one. And use the create external table as select or CETAS statement to shape an external table before you get created. So here I have create external table for Arability, and I specify where this folder will create files. So this is creating a new table and will write the contents of this data out to Arability Score /2116/01. And I will read from Mars Farming Raw Arability Score star.txt using open row set and select star. And then I can specify the data types, and then I could filter where the year of report date is 2116, the month of report date is 1. And I can write those out to my curated folder. This is incidentally exactly what I did to create the curated files. So I used the serverless SQL pool to read the 9,000 some odd files, parsed, wrote them out. There's a more efficient way to do that. You could pull the data in once and then write out individually. But I said, you know what? I'm going to do this. I'm going to do this way. And then I did it that way. So let's look at a few more demos. We're going to pop back in here to the CS Train workspace and create a Polybase table. I mean, I talked about some of this stuff, but let's actually see it in action. In order for this demo to make a lot of sense, we're going to need to pop this out and see create external objects. Is there a GitHub link with the demo code? There is, and I'll give it to you at the end. It's an incentive for sticking around. So do I have a symmetric key? Let's find out. I can run this, and by the way, I will have a symmetric key. So yes, I do have a symmetric key right here. If I didn't, I would create a master key. When you're running this on premises, one difference between that and running it in Synapse Analytics Serverless SQL Pool, create master key doesn't require a password or anything else. So you can just create it. It'll be created in your Serverless SQL Pool. If I don't have a database scope credential, I can create one. I would paste in my Sas token right here that would allow access. And if I don't have a data source, then I could create an external data source pointing to my data lake storage account and the folder, and then credential Sas token, right? If I don't have a file format, I'm going to create a Parquet format and make it available. So now that I have that, let's come back here and create an external table. So sys.external tables, where the name is Arability Test 2120-01. I'm going to read from Arability Score 2120-01 from my data source from my file format. I know that I have 3 separate columns. Note in this case, even though we're reading from Parquet, I still have to specify the structure of this table. So we saw an example with open row set where I could imply the structure of the table, but here I'm not allowed to do that. I've already created these objects, and just to prove it, we're going to run this, make sure that we get 10 results back. And I get my 10 results back. So, you know, life is good. And I can also filter, of course, just like any other table that you've ever worked with in your life. You can aggregate, you can group by, having clauses, where clauses, order bys, all of that available. And this, at this point, just feels like a table. It's just a normal table. So where are the external tables stored? The external tables live, basically that data never really leaves the data lake. I don't store the data from Arability Test anywhere. What happens is we pull that data in for the query that we need, process it, and then it drifts off into the ether. So this is entirely living in the data lake, which means that if I update that folder, if I add new Parquet files, the next time I run this query, I'm going to pick up those files. There's no ETL, there's no processing, and there's no mirroring of data or anything. It's just go out there, grab that data from the location on that external data source, and that's where the data is going to live. Here's my filter for plot 4462. So those queries, they will just run as you would normally expect. And I have another example of 2116. So here I have raw data, reading the Arability Score, everything, star.txt, and creating this external table, reading plot ID, et cetera, et cetera. And now let's go check it out. So are serverless SQL pools high trust and HIPAA compliant? Well, I'm going to pop open here a link to the Trust Center and say, this is probably where you're going to find the most luck in terms of getting those details, because in here you'll find information on the products and offerings. SP describe first result set will suggest columns. That is true, yes. Oh, I didn't create the table. Look at that. Look at what I did. Oh, I know why I didn't create it, because this takes a long time because I'm reading 9,100 files and am generating them as Parquet format. So that's why I didn't create it. But had I created it, A, we would still be here by the time my talk was over. B, we would then be able to run this query and get the plot ID and the number of records from this table. Let's look at some options for spelunking, which again, I think is probably the most interesting use case, at least for me, for serverless SQL pools. Can we create indexes on these external tables? No. So there are no indexes that you're going to create on the external table itself, for the same reason that the data doesn't live in SQL Server. So I can't create an index on data that's not in SQL Server. SQL Server can't control when the data is updated and would have to understand when the data was updated. Otherwise, your indexes would be out of date and possibly wrong. So short answer, no. Spelunking, ad hoc data exploration, querying arbitrary files and folders within a data lake, shaping those queries using T-SQL, and displaying and exporting the data. By the way, that lack of indexing, yeah, that can be a problem with performance for virtualization solutions. And there are a couple of problems with virtualization performance. So it's something to think about. One important thing is this is not intended to be transactional processing. So it's more for analytical querying. And we can look at ways kind of to have, I guess, use data folder structures as the equivalent of what you would use for an index. Like I'm going to show you here with the file path search. The open row set queries, you can load data from a single file. And here's an example of loading from a single file. Well, you can also load multiple files using that asterisk. So here I've got load for an entire folder, load everything named Arability Score underscore something, load Arability Score underscore one dot whatever. Maybe we have a dot text, dot CSV, dot whatever. And as long as they're the same file format with the same structure, this is okay. It'll load appropriately. One step further, if I use an asterisk in here, I can use file path and file name to get details on the file. So the file name, of course, is going to come from whatever the file name is for each star.parquet, for each file within that folder with the file type of Parquet. So I can use .file name, get the file name and the number of rows in that file. And what I'll end up with is each file has some number of rows in it, and it's approximately 1 million. I tried to max it out at about 1,024 times 1,024 full row groups. But if I have multiple wildcards, I can use file path to specify this wildcard within the structure. So here I've got star/star/star.parquet, year, month, file name. So file path 1 is year, file path 2 is month, and then if I used file path 3, that would be the same as the file name minus Parquet. So by year, by month, how many rows do I have? Group it by year and month. And I can see here's my year, here's my month, there's my number of rows. Suspiciously equivalent numbers of rows. Odd how that works out. I can even use these in the where clause. And this is where things get interesting. This is where, yeah, you don't have indexes, but you can still filter and save some scratch. So if I filter where file name is like C, then I'll run this. And by the way, I want to point out that this query took 3 seconds to run. It took, how long did it take for the previous one? 4 seconds for that. So what's happening here, we're not scanning all of the data. We're actually just hitting the metadata because all I've asked for is file name, row counts, and file path information. You can also take this data, export it out, CSV, JSON, XML, and that way you could write it out, you could save it someplace else. You can chart the data. using the charting library that's pretty similar to what you get in Azure Data Studio. Are external tables updatable from within Synapse or read-only? Read-only. There is no inserting, updating, or deleting of data from a serverless SQL pool, with the exception of create external table as select, in which case you create a new table, write data to a new folder. So there's no updating of data on the external data source using a serverless SQL pool. Can we apply a where clause for file path? Yes. So I showed file name. File path will have the same ability with a where clause. And actually, I think I have a demo of that right here. So let's find out if I do. All right. Reading data, file name, number of rows from all of my Parquet files in January of 2120. And we're going to group by file name. It took 2 seconds to run, and I get all of my files. So the file names, they're all GUIDs because of the process I used to create them, and they all have a certain number of rows in them. I could then say, give me the year and month and file name of each file. Or I get that second hyphen here. And while this is running, so is this more like Azure Data Explorer that supports log analytics workspace Custo language? No, this is T-SQL. So the Data Explorer pools are going to support the Custo query language. This is T-SQL explicitly. So here I have my results, year, month, file name, number of rows, and I could query through that as well. And I tried to use the Azure Data Studio shortcut for minimizing. What if I ditched the file name? If I want just year and month, I could run this, and it'll kick off. It'll take a couple of seconds to run through. It's taking longer because during demos, technology is shy. It knows that people are watching, and it gets really awkward. Here I have year, month, and number of rows. And I've got in this example a case where file name is like C, but I could say where file path 2, let's say equals 8. So August, the best month of the year. Julio Franco was born. How well does this deal with JSON data types, or is that even supported data type? So yes, JSON is a supported data type. You use the CSV format. Here are all the months, August. So you asked about file path in the where clause, file path in the where clause. You can also visualize this. We'll skip past that. I showed you the picture already. For logical data warehousing, historically, we've built physical data warehouses. We have known business problems that we solve, normal execution, things that run every month, every year, every quarter, things that are regulatory requirements, et cetera, et cetera. We can also create logical data warehouses, query from separate systems when that makes sense. And one area, something you'll probably hear a lot about, is the data lakehouse. This is a term that Databricks has coined. It's a combination of warehouse and data lake in one managed area. So historically, we've had, let's say over the past decade, the data lake. And I'm going to draw here that we have ETL processing that feeds data into marts. And there's more processing that's involved for data science and machine learning. There's more processing that's involved for reports and BI. The concept of the lakehouse is you have all of your data that's stored in the lake, and you query the lake directly for all of your needs. Does this work very well? I don't think it works right now. It's conceptually a really interesting idea. I think companies have put a lot of effort into making this a viable approach, and give it 3 years, and I think it'll be a really cool approach. I wouldn't bank on jumping into the lakehouse today, though. That said, Let's talk about the logical data warehouse in a serverless SQL pool. So it's not the same thing as a data lakehouse, but there are some similar concepts with the approach because I'm avoiding that ETL. Uh, I'm just looking at building up tables and structures. So let's try that out. For this, I have created a series of scripts, series of views, one for each of my primary measures. And so Arability Score is going to read the arability data as well as the year and the month out of the file path for each of these folders. And I've run this for each of the different views. I've got one for carbon dioxide, oxygen, etc. And also have a view for retrieving plot data from the plots JSON file. I could have another one that retrieves owners from the owners JSON file. And what this will give me is a set of views that I'm going to be able to query. And I'll be able to check it out in the data pane here, where I could hop into the Mars farming database and see my views as they exist. I also can just write queries. So I've got a view for water score. So we can see water score is a view that has month, plot, report date, water score, and year. If I do a quick run of that, we'll get a few rows back. There we go. I have my data. So January of 2116, and my plots and how they scored. I can also join all of this stuff together. So I have plot, arability score, CO2 level, et cetera, et cetera. Everything's joining on plot and a report date time. Conceptually, are views and external tables the same? No, no, not really. An external table, you could think of that. I wouldn't think of it as a view of the data, because a view is nothing more than a saved SQL query. So all a view is, I define this view as some select statement, and I save it and I call that thing dbo.plot. And now when you select from dbo.plot, you get the results. An external table is a bit more because it's not a SQL query. It is a structure of a remote data source. So both of them are generally read-only. Yes, you can insert into a view in on-premises SQL Server, but not in here. So they are going to be conceptually a bit different. And I have all of this stuff. So report date time, March 15th, 8 a.m. By the way, I'm adding in all of these filters here to make this a much faster query, because if I don't run them, if I don't include these filters, then I may scan the whole folder, when really all I need to do is scan the one folder with the year of 2118 and month of 3 for each of these measures. And I need to figure out a better way to do that, because I don't like the fact that I had to add in all of these to pre-filter out, when conceptually, logically, saying where plot is this and where these things join together, you'd think, yeah, they should be able to automatically figure out that if my report date is this and everything else is an equijoin, that I don't need the rest of these. But I did notice a big difference. This only took half a minute. It can take several minutes otherwise. But this will give me back information on each of those measures, everything joined together for this plot in this city with this acreage, remembering that none of this data actually lives in Azure Synapse Analytics. It is all in a storage account that is it's actually outside of my resource group. It's in a different resource group altogether. It's just a linked storage account. All right. Quick notes on securing data, because we're close to time and I want to talk about prices. There are ways to secure data in Azure Synapse Analytics, even if the set of security restrictions and rules aren't as robust as what you'll find with dedicated SQL pools or on-premises SQL Server. or an Azure SQL database because you can't do as much stuff. When you can't insert, update, or delete data, there's a lot less of a requirement to prevent people from inserting, updating, or deleting data. Still, you can control who can access the underlying data using Sas tokens. You can have credentials that are granted to specific people to use and can limit access that way. You can use role-based security and say people within specific roles are allowed to access certain options and add a person to that role. You can perform grants, revokes, and denies on objects, just like you would with any other edition of SQL Server. Administering bulk database operations will be required for OpenRowSet. So there was a question about permissions on OpenRowSet. This is a thing that will be required, bulk database operations. So it turns out that I actually had your question answered, even though I punted on it. So good job past me, bad job present me. Granting control. Control is a very strong permission. It's a really powerful word in SQL Server. Users can set up permissions. They can create or destroy external tables. They can destroy views. They can query data via OpenRowSet. I mean, that last one, it's not as powerful as the rest, but controls a lot of stuff. Save this one for admins, maybe for power users in a dev environment. There is no row-level security as such, but there was actually a really cool blog post showing how you can create something akin to row-level security using a combination of roles. So I can specify in a view if you're a role member and the value of a row is equal to something, then I can implement poor man's row-level security. And I could also do that as a function to make it easier to query the views. And then I can cross-apply my view with, or my external table or my view, depending on what it is, with the function, and thereby retrieve just the rows that are valid for that user. Money, very important. How much does this thing cost? Well, prices of each of the components are going to be different. For Serverless SQL Pool, $5 per terabyte processed. But what is a processed terabyte of data? This includes if you read the data, if you read metadata, if you write the data to a temp table, or if something happens, maybe there's lazy spooling and the spool gets written to a temp table. If you have data written to storage via CETAS, if you have data transferred between nodes, if you have data written out into Management Studio or into this web client, each query has a minimum of 10 megabytes of data processed. If you get one row from one JSON file that had 2 rows of data, 10 megabytes of data. So this is not a transactional system where you hit thousands of transactions per second. This is more of an ad hoc processing and analytics system. How do I save money? We want to use the right file format. Typically, it's going to be Parquet for the reasons I talked about. It compresses well. You can read metadata. If you read the metadata and don't read the raw data, you only get charged for the metadata processing, probably that 10 megabytes. Smaller result sets return. Every row that gets written out think of it as dollar signs getting written out. And so many dollar signs, you start getting charged. I do have a note on compression involved here. There is some fanciness there, but also use filters. Use filters on file name and file path. Narrow down what you're accessing. Use OpenRowSet for ad hoc queries. Narrow down to the smallest number of files. Pre-calculate things if you have something that's used very frequently, because then you can just query the pre-calculated result. So that's where you could use CETAS to take a really expensive query, write it out, and then you can select from it. And to calculate the data process, the last thing we're going to do before I get the vaudeville ringer is figure out how much money did it cost me today to give this talk. And the answer is $0 because I only processed like 700 megabytes. So even with that, it's not that expensive. This is actually very price effective unless you're querying petabytes of data very regularly. So wrapping up, this has been a look at the serverless SQL pool in Azure Synapse Analytics. It's a second cousin of SQL Server on premises, but I think it's welcome in the family. If you want to learn more, if you want to grab the slides, if you want to grab the demos, the code that was involved in this, go to csmore.info/on/serverless. If you have any questions after this, please feel free to follow up with me via email or hit me up on Twitter. And with that, let's see. Maybe I missed it. Can these projections be written back to a storage account, data warehouse, or something else? Yes, with the CE TAS, create external table as select, you can write that out to your storage account, assuming that you have the right permissions on your Sas token. With that, I want to say thank you so much, everybody, and have a wonderful rest of your day.
Thank you so much, Kevin. That was an excellent session with a lot of good Q&A. And of course, you're an awesome presenter with good content here.